Hello friends, welcome back to my channel Key to Learn. In this video, we are going to learn about Python 3. This is the chapter 1 of the Python 3 Masterclass.
Hi, and welcome to this section, which is going to be a quick refresher on Python 3. First thing we'll look at will be the Python type hierarchy, and we'll limit our focus to the data types that we're going to work with in this course. Next, we'll look at multi-line statements and strings. Now, we are interested in multi-line statements because we sometimes want to write our code over multiple lines for readability reasons. We don't want to have to scroll back and forth necessarily as we're looking at a line of code, or just to break things up neatly. And then while we're at it, we'll also look at multi-line strings. Then we'll look at naming conventions. How do we name our variables? How do we name our methods? How do we name classes? And we'll look at some of the rules and some of the suggestions for these naming conventions. And it really becomes important to understand these naming conventions when we start getting into object-oriented programming. But we'll cover that in a later section in this course. Next, we'll look at conditionals. So like if statements, for example, are conditionals. Then we'll look at functions. Now, this is not going to be a deep dive into functions. We're just going to look at the basics of how to call a function, how to define our own functions and parameters, but very simple stuff, just the basics. Then we'll take a look at loops, and in particular, we'll cover the while loop and the for loop. And then we'll also look at the break and continue statements, and we'll also look at how they behave when you have them in try statements inside a loop. What happens with the break and the continue? And then we'll also look at the else clause that can be added to for loops and while loops. All right, so thanks for watching, and I'll see you in the next video. Hi, and welcome to this lesson on the Python type hierarchy. Now, we're only going to cover a subset of this hierarchy, and in particular, this is the subset that we're going to cover in this course in quite a bit of depth, along with some other things as well. So we can start with numbers. Numbers are something we use, all the time in programming, and we can divide numbers up into two different sections: integral numbers and non-integral numbers. And by integral numbers, I mean things like integers, right? 1, 2, 3. But we also have booleans. Booleans are actually also integral numbers. They're actually integers. In non-integral numbers, we've got a few more. Floats is probably the most common one. So if you write, a equals 3.14, that 3.14 is a float, which is implemented as a double in the underlying C. We also have complex numbers. Complex numbers, remember, are numbers that have a real and imaginary part. So we'll cover that, not really in depth. This course is not about complex numbers, but they are actually implemented in Python. We'll also look at decimal numbers. Now, decimals and floats kind of are used for the same thing, to represent real numbers that are not integral numbers, like 3.14. But it gives us a little bit more control on the precision of the number, right? And there's different ways that that precision is implemented between decimals and floats, and we'll cover that in some detail in a later course. Fractions, well, fractions is just basically your rational numbers, 1/3, 1/5, 1/8, 20, 17s, things like that. That's an interesting way of dealing with numbers, because let's say you deal with a number like 1/3. Okay, that's a rational number, and it has a value, a very specific value, 1/3. But if you try and represent that as a float or even a decimal, then you're really looking at 0.333 recurring, and we cannot represent that exactly in the programming language that we're using, in any programming language, because we don't have an infinite number of precision, right? We don't have an infinite amount of precision to store 0.333 recurring, which is an infinite, recurrence. So if we have to really deal with exact numbers, so if we want 1/3 plus 1/3 plus 1/3 to be precisely equal to 1, then we need to use fractions. The next part are collections. Now, collections can be broadly divided into three different parts. We have sequences, sets, and mappings. So under sequences, we can further subdivide that into mutable sequences and immutable sequences. And the ones that we'll cover in this course are lists, which are mutable sequences, and tuples, which are immutable sequences. They're essentially the immutable variant of lists. But strings is also a sequence type, and it is also an immutable type. Then we have sets. Now, sets can also be broken down into mutable and immutable, and in this case we'll cover sets, which are the mutable sets, and we also have something called frozen sets, which are the immutable equivalent of sets. And lastly, we'll look at dictionaries. Now, dictionaries and sets, we'll see later, are actually related. They're actually implemented very similarly. Both sets and dictionaries are basically hash maps. The only difference is that sets are not key value pairs. It's basically like having a dictionary that only has keys but no values. So we'll look into that in a lot more detail in a later section. Then we also have something called callables. Now, what are callables? Well, callables are anything that you can invoke, anything that you can call. So like a function, for example. A function is a callable. So obviously user-defined functions. Then we have generators, which are things that we can use to do iteration, and we'll get into a lot more detail about generators in a later class. Then we have classes themselves. Classes are callable. We have instance methods, which are just functions, but they're, inside a class. So they become instance methods once the class gets instantiated. We also have class instances that are actually callable. You can define this method here, dunder call dunder, that allows the class to become callable, the object or the class instance to become callable. And we'll get into that again in a lot more detail in the object-oriented section. And then you have built-in functions, right? Python has a lot of built-in functions like len, to get the length of a sequence, for example, open, if you want to open a file. You also have built-in methods, and really they're no different than instance methods. But for example, if you have a list, well, lists have an append method, so you can append an element to the end of the list. These are all callables. And then we have these things hanging out there that kind of are out on their own, and they're singleton objects like none that we've seen before, right? None is an object that exists, and whenever you set a variable to none, it always points back to the same memory address that we have for the none object. We also have something called not implemented. We'll take a look at that in more detail when we do object-oriented programming. And then we have the ellipsis operator. Again, we'll look into that in detail when we look at sequences and strings and lists and so on. It can be used for slicing. All right, thanks for watching, and I'll see you in the next video. Hi, and welcome to this video where we're going to talk about multi-line statements and multi-line strings. So a Python program is nothing more than basically a text file, right? A text document that contains physical lines of code, and you write your code over multiple lines. You use the enter key on your keyboard to move to a new line, right? So we'd call that a physical new line. Now that code is then passed by the Python compiler, and it then combines certain lines and makes up logical lines of code. And your logical lines of code are then tokenized so that the Python compiler and the interpreter can basically interpret what your code is trying to do and actually execute that on the computer. So physical lines of code will end with a physical new line character, and logical lines of code, once they've been tokenized and passed and so on, will end with a new line token. So how that gets done and so on isn't really important. But what's important is that we have to realize that there's a difference between a physical new line character and a logical new line token. They're not necessarily the same thing. Very often they are, but not always. So sometimes physical new lines are ignored. And they're ignored in order to combine multiple physical lines into a single logical line of code, which is then terminated by the logical new line token. And that's what allows us to write code, over multiple lines that technically should be written as a single line. Right? We can actually write it over multiple lines. And why would we do that? It's really for readability, right? It allows us to make our code more easy to read. And that's really, really important because, the compiler, the interpreter really doesn't care, whether you, write it over one line, over two lines. At the end of the day, it's going to recombine lines into single lines as needed. It's going to tokenize everything. It doesn't care about human readability. But as developers, we need to care about human readability because we are reading our code. Other people might be reading our code. Or you might even be reading your code 6 months later and trying to figure out, what was I doing? So it's really important to make code readable. It's important to put comments. It's important to format things nicely. And this allows us to do that. So this conversion between physical and logical new lines, right? This removal of physical new line characters is done either implicitly or explicitly. Implicitly in some cases, and in other cases we have to do explicit line breaks. So let's take a look at the implicit first. So for implicit, really we can use it in things like expressions which are like list literals, right, that start and end with square brackets, tuples with the round parentheses, dictionaries that use the curly braces, and sets that also use curly braces. And as I said before, it kind of makes sense because dictionaries and sets are very, very tightly related. And then also function arguments and parameters can also be split over multiple lines. And they also support inline comments. So let's take a look at how this works. So for example, for this list over here, 1, 2, 3, you don't have to write it over a single line. You could actually break it up over multiple lines. And these physical new lines will be implicitly removed by Python. Now in this case it doesn't make much sense to write this list this way, but suppose that these were like long strings. Then it would make more sense maybe to break it out over multiple lines so it's easier to read. Or maybe you have a nested structure where you have dictionaries that contain lists, that contain dictionaries that are very typical of things like JSON objects, for example. Then you probably will want to break that over multiple lines and do nice indenting so it's easy to understand and read that particular object. You can also include inline comments. So at the end of every line after before your physical new line character, you can insert a comment that will be stripped out by Python. So this is perfectly legal to do. Same thing with functions. You don't have to write all your parameters over a single line. You may write it over multiple lines. And again, it's for readability. You can even comment, let's say, certain parameters if you want this way. And then when you call the function, well, you can do the same thing. You can break up your arguments over multiple lines. You can even insert comments, right, within, before you do your new line character. So remember that what happens at the end of the day is that this comment is stripped out, and this new line and this new line are stripped out, and you end up with def myfunc a comma b comma c, as if you had written that. Okay, that's how Python is going to basically combine these different physical lines into a single logical line. And the same thing happens here. This comment here is going to get stripped out, the new line character over here is going to get stripped out, and this is going to become myfunc 10 comma 20 comma 30. So this is where implicit works. Now, there are sometimes cases where we have long statements and we want to break those up over multiple physical lines as well. But Python will not do implicit removal of your new line characters in that case. You have to explicitly specify that I'm doing a continuation of the code. And you do that by using this continuation character, the / character. So multiple line statements are not implicitly converted, okay, into a single logical line. Keep that in mind. So you have to use the /. So for example, if you want to break up an if statement that has multiple ands and ors and it gets really complicated, and it might make more sense to break it out over multiple lines in order to understand what's happening, what that piece of code is doing. Again, readability. This won't work. You cannot do that, right? If Python's going to look at this, it's going to put the new line token here, it's going to say, well, this is invalid. Doesn't work, right? Because it didn't find the colon. So instead, what you can do is you can do an explicit line continuation using this / character, and this will work just fine. Now, the one thing is you cannot put in comments after these, backslashes or even before them. You have to put it, if you want to put a comment, you're going to have to put it either above, below, or you can put it right after the colon as well. That's fine. But you cannot make a comment part of a statement, being inside a statement, not even a multi-line statement. So that won't work. So this, for example, is not legal. That won't work. All right, the next thing we need to look at are multi-string literals. So we can also create strings that span multiple lines in our physical, code. And we do that by using triple delimiters. Whether you're using single or double quote delimiters doesn't matter. You just triple them up. So instead of using a single quote or a single double quote to delimit the string on either end, you use triple. And that then allows you to write strings over multiple lines, over multiple physical lines, as in this example. So we have a triple single quote. This is, got a new line, we hit the enter key here, and a multi-line string continues, and then we end the string. And you can do the same thing using double quotes, so whatever you want to use. Now, you have to really be aware that this works a little differently than the implicit, for example, continuation that we had with lists, where it was stripping out the new line character. Here, Python is not going to strip out the new line character. So when you print the string out, it will retain this new line character. In fact, it will retain any character that you've typed into that string, whether it be a new line, whether it be a tab, whether it be a Unicode character, or some hidden, character that doesn't print, but it's still there, right? So anything you type is going to be in that string, including multiple spaces and things like that. And so it's important, if you're trying to get a string that's formatted for display, you want to be sure that you don't type extra characters that allows you to line things up in your code, but then doesn't line up when you print. And we'll see examples of that throughout this course. So these are just regular strings, so you can use escape characters if you want, like \n, \t. You can use string formatting, you can apply the format method, you can do all that stuff. They're just normal strings. They're no different. So multi-line string is just a regular string. The only difference is that you can have that string, content, that literal, span multiple lines. Now, one thing I want to point out is that multi-line strings are not the same thing as comments. Now, they can be used as comments, especially with things with, that we call doc strings that we'll look at in a lot more detail in the object-oriented section. But strings and comments are not the same thing. So yes, you can put strings inside your code that are not assigned to a variable, that are just sitting there in your code. That's perfectly fine. And you can use that for doc strings, for documentation. But these are not comments. They're not the same thing. So when Python compiles your code, those strings will be part of your code. They'll be compiled and they'll be put into your compiled bytecode. However, comments are tossed out. They're not. So they're different things, not the same. All right, so let's switch to some code and take a look at how all of this works. So we're going to start with a list. Now, a list can be written over one line, let's say something like that. But sometimes you may want to write it over multiple lines, in which case we can do something like this. And you don't have to put one item per line. You can put how many, however many you want. And we'll still get a regular list. Nothing has changed. It's just implicit line continuation. Now you can also add comments. So let's say we say 1, and let's call it item 1. Now you have to be careful where you place the comma to separate your items. Because if you put a comma here, then this comma is part of the comment, which means that it's not going to be a valid Python statement. So if we do 2 here and we try and run this, we get an invalid syntax error. Well, yeah, because there's no comma between the two, but there is a new line, right? So instead, what we would have to do to fix that, there's one of 2 solutions. First one is to put the comma right after the element, but before the comment. That's one way of doing it. The other way of doing it is just to put the comma before the next element. And you can do that as well. And in both cases, it will do the same thing. And if we look at the contents of A, you'll notice it's just 1, 2. The comment was ignored. Okay, now this works the same way for, tuples. So A equals 1, 2, 3. We can put a comment here. We can put a comment here. We can put as many comments as we want. And we just get a regular tuple. Nothing different there. Same thing with sets, which I won't show you. It's the same thing, and dictionaries as well. I will show you that one very quickly. So let's say we have a key value like so. Let's make it a value of 1. We can add a comment, right? So we can say this is value for key 1. And again, where we place the comma is important, either here or at the beginning of the next item. I'll put it at the beginning of the next item. Key 2 to value for key 2. Now, we have to be careful here as well, because you'll notice that I have a comment on the last line, which means that that closing brace over here is actually part of the comment. So if I try and run that, I'll get a syntax error, right? So we have to fix that by putting it on its own line, right? We have to do it that way. And now that will work, and we get a regular dictionary, okay? Now you can do the same thing when you have a function. So let's look def my func. We can certainly put a comma b comma c in this fashion, right? But maybe I want to break it up. Maybe I've got lots of parameters in the function, or I've got long names, or maybe there's some other reason why I want to break it up. And in this case, I'm going to break it up, let's say, this way, right? So we've broken up the function this way. And we can add a comment, right? We can say this is used to indicate blah, 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 you know, and another comment here, right? Now, again, you got to be careful about the placement of your commas. Don't place them after the comment, otherwise they'll be part of the comment and ignored, and you'll have a syntax error. Okay, so we can start with that, and then we can just say, you know, print a comma b comma c. So this function will just print whatever was passed in. Now when we call the function, we can do the same thing. We can call function with, let's say, 10, 20, 30. Okay, that works just fine. But we can also call it by splitting the values over multiple lines. That's fine as well. And again, that's fairly useful when you're dealing with functions that take in a lot of parameters, and maybe the parameter names are long. Maybe it's something that allows you to connect to a database, so you need to specify the database, you know, the server, the database, maybe the table, maybe the query that you're trying to run. So very often, you know, you end up writing function calls over multiple lines, probably more often than you do writing the function headers themselves. So in this case, we could do something like this: func 10, and, you know, comment here that describes maybe what the value is, 20, another comment, 30, another comment. And again, we have to be careful not to make that closing parentheses part of the comment itself. And this works just as before, nothing different. Okay, so that's kind of the line continuation, the implicit line continuation. Now let's take a look at explicit line continuation. So let's say if we have a equals 10, b equals 20, c equals 30. Let's say we have these three variables, and we write an if statement. And we say if a is greater than 5, and b is greater than 10, and c is greater than 20, which is going to be true in this particular case, then we can print yes. Okay, so that works just fine. Now, sometimes your expressions here might become very long, or it could be other statements too. It's not just an if statement. But maybe the line just becomes too long, and it is preferred in Python to keep your line length under a certain number of characters to make it more readable on a variety of screen resolutions and screen sizes. So part of some of the best practices in Python, which we'll talk about later actually, it's called a PEP 8, and we'll take a look at that in an upcoming video. So let's change this, and let's put in line continuations. Let's say that I want to have each expression, each sub-expression, you know, those comparisons on different lines. Then I can do a line continuation character, essentially, using a backslash. Okay, and then we do another one here, and there we go. We're over 3 lines. Now, the indentation actually doesn't matter at this point, because remember, it doesn't matter how you indent your code here, because those new lines are going to get removed and it's going to become a single line. So in this case, I'm going to choose to indent it maybe this way. And that's perfectly fine too. And as you can see, it ran fine. So the line continuation character is just something you can put in wherever you want to break a physical line or a logical line into two physical lines or more physical lines. The next one are multi-line strings. Now, multi-line strings are done with triple delimiters. So here I have 3 single quotes followed by 3 single quotes. That's the ending and closing quotes. And we can type something in there. This is a string. Okay, and if we print out A, this is a string. It's still a string. So the triple delimiter just is a regular string. But what's different about the triple delimiter is that we can split it over multiple lines. As in this case, and you'll see the result is this \n, right? And this is why I just wanted to print it out this way, is a string. So that new line character was preserved. So if we print it for display, let's say from the program, we would actually get it over 2 lines. Now, what's important to realize is that anything you type in here, so if we do something like this, A equals triple quote, so now we have a multi-line. This is a string. And let's say I put in a few extra spaces, and maybe I'll put in an extra carriage return here. I'll indent it some more. This is a string that is created over multiple lines. So now if we look at A, you'll notice that we have those carriage returns and those spaces are there as well. So if we print A, then we get exactly what we typed over here. So that's kind of important to remember, because if you're trying to, let's say, define a multi-line string to create some text that you want to display to a user, let's say on the console, then if you try and line things up so that the string looks good in your code, it may actually not look good in the actual console. For example, if we do something like this, A equals, let's say, some items, and I'm trying to, line it up here as my list. So I'll go 1, item 1, 2, item 2. Okay, it looks good in the code, but if you print it, then it doesn't look that great, right? It was indented over here a lot more than I had, right? Because this seemed to line up with just 1 character difference, right, between this line and these items, and this no longer does. So just something to be aware of, okay? Now in particular, let's look at it this way. So we have def myfunc, and so now we have indentation already, right? We're using A equals, that's indented inside the function. And if we do a multi-line string and say a multi-line string, I hit enter, that is, now the program automatically shifts my line of code to the proper indentation, and most of the Python IDEs will do that as well. So a multi-line string that is indented in the second line, and it will just, this function will just return that string. Okay, so there we go. Now if we print myfunc called, then you'll notice what happened. That is indented in the second line was actually indented. Because why? Well, this entire thing here is the string, which means it includes that indentation that was put in automatically for us. So in a case like this, you've got to be careful. You have to really unindent it if you want it to be not indented in the display. So it looks weird. It looks like you're breaking, the indentation, but you're not. That's because remember that this is basically, a line continuation. This is a single entity right here. This is a single string literal. And so whatever's inside, it doesn't matter if it's indented or not. So in this case, if we do this and now we print it, now we get maybe something more like we would have expected. All right, thanks for watching, and I'll see you in the next video. Hi, and welcome to this video on identifier names. And in particular, we're really just going to look at some rules that we need to follow when creating identifier names and some conventions as well. So let's start with the fact that identifier names are case sensitive. In other words, my var with that lowercase v, my var with this uppercase v, or ham with a lowercase h, or ham with an uppercase h, these are all different identifiers. So identifiers are case sensitive. So you could write, one variable as ham, one variable as ham with a capital H, and you could use both of those in your code as separate identifiers. Really not recommended that you do so, at least not with variables. There is a case where this might actually be useful when dealing with classes, but generally not something you should do. It can be pretty confusing if somebody's reading your code. So identifiers must follow certain rules, and they should follow certain conventions. And let's take a look at what those are. Let's start with the musts first. So they must start with an underscore or a letter, A through Z or capital A through Z. Now, this is actually a little stricter than reality, because you can use other characters beside A through Z and A through Z, but you got to be a little bit careful about which ones you use. It gets a little more complicated. You can use also Unicode characters. Well, not that these aren't Unicode characters as well, but I'm sticking to the ASCII set, basically. So be careful with that. The easiest is just to say we'll stick through A through Z for the letters. So they must start with an underscore or a letter, and then they can be followed by any number of underscores, letters, or digits. So really the thing here is that you cannot start an identifier with a digit. Okay, so don't try that, that won't work. So for example, var, my var, index1, index underscore 1 are all legal names. Underscore var is legal as well. Double underscore or dunder var is also legal, as is dunder lt dunder. That's also a legal identifier name. Now I've highlighted these in a different color, and I'll explain that in a minute, but these kind of forms of variable names by convention have a specific meaning attached to them. So the other thing too is that identifiers cannot be reserved words. Then what are the reserved words? Well, none, true, false, and or not, if, else, if. You get the idea. Basically the keywords that you use to program in Python, right? Def, lambda, return, in, is, that we've seen before, try, except, all these are the reserved words. And as of our current version of Python, that's it for now. So there's not a whole lot to remember, but don't use those as identifier names. So let's get to the conventions. So let's take a look at what those conventions were, the ones that I highlighted. So if you have a single underscore in front of your identifier name, let's say you create a variable in a module and you name it underscore my underscore var. Because it starts with a single underscore, it is a convention that is used to indicate that this is an internal or a private object. There is no concept of private really in Python. Everything's public. So, basically we're saying, hey, I want to indicate to anyone looking at my code or anyone using my code that they really shouldn't mess around with this variable. So I'm going to give it an underscore, as the first character. So that is really just a convention. Now what happens though is that if you run, let's say, from module import star, and this underscore my var is inside this module, then it will not import it. So the Python interpreter looks at that and says, okay, you probably mean this to be a private object, so it doesn't import it. Now that doesn't mean you can't access it. You can still access it. You can't import it this way, but there are other ways to access it. Okay, let's look at the double underscore. Now the double underscore is used for something called name mangling that we'll look at in detail when we do the object-oriented section. And name mangling basically changes your variable name in a very set way that can be useful for inheritance chains. If you have the same name, the same, let's say, attribute, let's say you do a property in a class, and you have the same attribute in a chain of classes, then how do you differentiate which is which? And this is where the name mangling comes in. And so when you want that to happen, you use this dunder in front of your property name, for example. And we'll see that in a lot more detail. And the last one is the one that starts and ends with a double underscore. So dunder, my underscore var, dunder. That has a very specific thing. These are really system-defined names. So Python kind of reserves its naming convention in this way for certain things. And it has a special meaning to the interpreter, which means don't invent them. In other words, don't go and create your own variables that start and end with a double underscore. Just stick to the ones that are predefined by Python. Now, what are they? Well, there's a slew of them, and we'll see a lot of them throughout this course. But for example, you have the init method, to initialize a class. Well, that's the double underscore init double underscore function. And then when you create a new class, it will call that particular function. It's going to look for that function. Now the same thing happens. Let's say you have two objects, x and y, that are instances of, let's say some custom class that you've written, and you want to compare them. You want to say x less than y. Then what's going to happen is that the Python interpreter is actually going to run this underscore underscore lt underscore underscore method that it expects to find in this object, and then pass it the object y. So this operator here actually gets evaluated by using this expression over here. And again, Python will look specifically for this method name when it finds less than. So that's why these are system defined. Don't invent some. You never know what could happen in future versions of Python. Maybe, whatever you decided to use gets used, in the Python standard later, and then there's going to be a conflict between the two potentially. Okay. So other naming conventions, and this is just a very, very small excerpt of the PEP 8 style guide. If you want to look it up, I really strongly suggest that you read it. It's not that long. It's a very interesting read, actually. And it's called PEP 8. Just do a Google search for PEP 8 or Python PEP 8 and you'll get it, and I'll show you the link in a few minutes. So this is how we name different things, like packages. So packages should be short names, all lowercase names, and preferably no underscores. So for example, you might create a package called utilities, right? Note, everything is lowercase, single word, and no underscores. That's the preferred style for naming packages. For modules, we also want short, all lowercase names, but they can have underscores. So for example, db underscore utils would be fine, as would be db utils in one word as well. Really only start using the underscores if you really need it to differentiate the words maybe in your module. Classes. Now classes is different. The convention there is to use cap words or upper camel case, which means that all the words are linked together. There are no underscores, but the beginning of each word is an uppercase letter, including the first letter of the variable. Functions, well, functions should be lowercase, and the words can be separated by underscores, which is called snake case. Right? So for example, open account. So this might be a method in your bank account class called open account. Variables should be lowercase, words separated by underscores, snake case, same as functions. So basically we follow the same convention for naming variables as we do for naming functions. So for example, account underscore ID. Constants are all uppercase and the words are separated by underscores. So for example, minimum annual percentage rate, min underscore APR, would be a valid constant name. Now obviously you don't have to follow those conventions. You can follow your own conventions. You also may want to follow conventions, especially if it's, let's say, an external interface that you're providing to, to other people, and it may need to conform to what they're used to, in which case that's fine. There's nothing wrong with breaking away from conventions as long as you try and remain consistent within your own code. But these are best practices, and they've been fairly well thought out. And so it's really, I think, recommended to read that style guide, or at least skim through it and see what the main points are. So you can find it at this link over here. But again, the easiest, just do a search for PEP 8 and you will find that link to there. There's lots of other things that they mention in that. In particular, this quote by Emerson, "Foolish consistency is the hobgoblin of little minds." And that's kind of what they start off with. So it's a guide, it's a style guide. It doesn't mean that you have to follow it, and you don't have to follow it all the time without thinking. Sometimes you want to break away from your convention for some reason or other. That's perfectly fine. The main goal really of all this is to make your code readable, and by following these guides is you make your code standardized in such a way that another Python developer that's used to that guide will understand without having to go and look into your code in detail that something written this way is a constant. Something written this way is a class. These could be, function names or variable names, that's fine. But it helps to really kind of understand how the code sometimes is structured. All right, thanks for watching, and I'll see you in the next video. Hi, in this video we're going to take a quick look at conditionals. So conditionals, we'll look at the if statement, and we can write something like this. So a equals, let's say, 2, and then if a is less than 5, print a is less than 5, and we can leave it at that. That's the if statement. So in this case, a was 2, so it was less than 5, so we printed that. If it's something greater than 5, maybe 6, then it won't do anything because, well, that's it. It's not going to execute this line if a is greater than or equal to 5. If we wanted to execute, we can put in an else statement, and that will therefore happen when the condition is not met. And we can say here, print a is greater than or equal to 5. And we have that result there. If statements can also be nested within each other. So let's say we have a equals 10, and we can say this, if a is less than 5. And you can nest the if statements either inside the if block or in the else block. It doesn't matter. Either one will support it. Basically, this is just a code block that can contain anything you want. Any other, Python code you want, comments, anything you want. So if a is less than 5, well, let's print again, a is less than 5. Else, and here we'll do another test. If a is less than 10, well, we'll print and say that a is greater than or equal to 5 and less than 10. It's going to be between 5 and 10. Obviously, if a is less than 10 but greater than 5, well, if it's greater than 5, it's going to fall into the else statement. So it's going to be greater than or equal to 5, and here less than 10. Okay? And then we can also put in an else statement. And here we'll say print a is greater than or equal to 10. Oops. Okay, so because a was 10, we printed a was greater than or equal to 10. If we make a equal to 8, then we see that a is between 5 and 10. And if we make a equal to 4, we get a is less than 5. And we can test the edge conditions, like 5, and we get precisely a is, greater than or equal to 5 and less than 10. There is, of course, an easier way to do it than writing nested if statements this way. In other languages, you have something called the switch or the case statement, and you have that in, Java and C# and Swift and so on. What you don't have that in Python. The closest that we have to a switch or case statement in Python is the elif. So let's take a look at that. So we'll do the same problem again. We'll say if a is less than 5, print a is less than 5, elif. So it's like saying else if, and now we have to give the condition again. So we'll say a is less than 10. We'll print that 5 is less than or equal to a is less than 10. And we can put as many elif statements as we want. So we can say elif a is less than 15. Then we'll print and say that 10 is less than or equal to a is less than 15. Okay, and we can even put another one. I mean, as I said, we can put as many as we want. Let's put 20 here and print 15 less than or equal to a less than 20. And then we can finally put our else at the very end and say a is greater than 20. Okay, so this is how it works. Now obviously we can test out each branch, so we can put a equal to 3, it falls inside this branch here. If we put a equal to 8, falls inside this branch. If we put a equal to 12, falls inside this one. 18, you get the picture. And then the last one as well. Okay, so that's the if and else statements. And that's the most common way of branching, of basically, having a conditional evaluation. So we execute a piece of block, a piece of code, a block of code, based on a condition being satisfied or not. The other thing is that Python also has something called a conditional expression, also known as the ternary operator. And the way it works is that it says the following. It will return x, so it will evaluate and return x if some condition is true. Otherwise, it will return y. So it's a bit like saying the following. So if we say a equals 25, if a is less than 5, print, well, I'm going to put a b here. I'm going to say b is equal to a is less than 5, else b equals a is greater than or equal to 5. And now we'll just print b. So this is just a regular if-else statement. But we can use the ternary operator. Let me fix that typo over here. I don't like seeing that. Okay. So we can write this in a different way. We can say the following. We can say b equals a is less than 5 if a is less than 5, else a is greater than or equal to 5. And it just reads pretty straightforward. B is equal to this, if this, otherwise this, right? And that's a pretty natural way of reading that. And if we print B, you'll see that we get A is greater than or equal to 5. If we make A equal to 4 and we redo, now this just returns a value, right? This is an expression that gets evaluated to a value. So we don't have to assign it to a variable in this interactive Python as usual, because remember, if we do something like this in the notebook, it just returns the value of whatever expression is there. Well, we can do the same thing with this over here. We can just return the value. So let's make a equal to 4, okay, and let's just print out what that returns. And it returned the string a is less than 5. So that's the ternary operator. It's pretty useful for having short kind of one-liners. But of course, it can't handle blocks of code in here. It's really almost more like an and or Boolean operator in the sense that it's not going to return, what the ands and the ors returns, but it's a slightly different construct, but it's an expression that returns a value. It's not something to evaluate blocks of code. For that, you have to use the if and else statements. All right, thanks for watching, and I'll see you in the next video. Hi, in this video we're going to take a quick look at functions. So functions, well, there's lots of functions that are built into Python. Some are available just by default. As soon as you start running Python, you have a lot of things that are available. For example, if we take s to be some kind of list, then we have the len function, which just returns the number of elements in s. So that's built in. Sometimes you have other built-in functions that Python provides that you have to import from some module. So for example, we might have from math import square root. So now we have this square root function available to us, and we can just call it this way. Right? So we get square root of 4 is 2. You can also just import the entire module, in which case you'll have access to everything that's inside that module. For example, math.py, which is a constant that's available in there, or all the functions as well. So we can take maybe the exponent, so e to the power of 1. So that will give us the value of e. So those are things that are built in, but we can also define our own functions. Now, functions are just objects that basically contain some stuff, including our code when we write a function, and then we assign that to a name, to a variable. And that's what the def statement does. The def statement, essentially, you specify the name of the function that you want, so maybe func1. Then we have parentheses that we use to put in parameters. In this case, I'm not going to define any parameters, but we still need the parentheses there. And we might say print running func1. Okay? So here we have our function. Now we can call this function, we can invoke the function, and at that time, then Python will go ahead and run what's defined for that function. Now you have to be careful. You cannot just call the function like this. If you do that, what you're really getting is the function itself, right? The function exists as an object, and it's called func_1. To call the function, to run the function, or to invoke the function, you have to say func_1 with the parentheses. In this case, we have no parameters, so no arguments. And there we go. We see that it ran running func1. Now we can define variables, parameters, basically, that we're going to pass into the function, and we just give them a name, and this is going to be a name that's going to be local to the function, and maybe we're going to return a times b. Now you'll notice that there's no types. We'll get into that later, but you know there are no static types. You don't define the type in Python of what you have in your function. Now, if you want, you can actually put in something called an annotation. You know, something like maybe int, saying int. So basically, you're saying, hey, I'm going to be passing 2 integers. That's what I expect in this function. But this is just a documentation thing. It's got nothing to do with the Python interpreter actually looking at this. And if you pass in, because if we do this, we can certainly pass in 2, 3. So we pass in some integers, but we can also pass in, let's say, a string and an integer. So let's do that. Which returns the string times b, which just repeats the string a certain number of times. We can also call maybe a list. And we'll repeat it 3 times. And here we go. We have the elements repeated 3 times in that list. So this really didn't stop us from, calling either of these functions with these parameters here. So it's just a documentation thing. Many IDEs will use that so that as you're typing your code and as you're calling func_2, it will tell you, hey, you need a parameter of type int, you need a parameter of type int, or whatever the case may be. Other libraries, external libraries, can use that to understand what it's supposed to do, what it's supposed to pass in. But really, that's not built into Python. Python is very polymorphic, and here we see an example of that, right? We can pass 2 integers, and the star operator will work. You can pass in a string and an integer, that will work as well. You can pass in a list and an integer, that will work as well. Now, it doesn't work in all cases, right? Sometimes things don't work. So if we pass in 2 strings, that's not going to work because, well, it's not defined. We don't have multiplication defined for two strings. So this is an example of polymorphism. We'll come back to polymorphism in a lot more detail later in the course when we start looking at object-oriented programming. So anyway, back to functions. So we can create our own functions. And to call and invoke the function, we just have to put in, the round brackets. And if we have any parameters, we put our arguments in there as we call the function. So pretty straightforward. The next thing is that functions are just like a variable in the sense that it's just a name. This func2 here is just a name. And as we saw earlier, if we don't call func2, if we just do this, then it tells us that this is a function. This is a function that exists and it was assigned to the name. And that's what def does. Def basically, as soon as Python encounters this statement over here, this def statement, it looks at this and say, okay, you want to create a function which is going to be named func2. It's going to have these parameters, and this is the code that's inside func2. But it doesn't execute the code inside func2 at this point. It doesn't even really look at it. It kind of stores it and puts it away into an object. The only thing it does is it creates the function, and the metadata around the function to include things like the parameter list and so on, and also the code block that's associated with the function. But it's not the function itself. In fact, what we can do therefore is we can call functions inside this that haven't been defined yet. So if you have a piece of code like this, so def func1, let's redefine func1, and here I'm going to return the result of calling func2. Now you'll notice that func2 hasn't been defined yet. So here I'm going to now define func2, and actually we already have func1 and func2, and so you might think that this is working because we have that. So let me go ahead and call it func3, and we'll call func4. We've never seen those functions before. They don't exist. They're not built in. So let's see if this works. And then here we'll return running func4. Okay. So at this point, I can just run this code, and these functions have been defined. They're fine. They exist. They're there. But you'll notice we didn't get an error, because even though we called func4 here, it didn't exist. It wasn't even defined yet. But that's okay. Python doesn't care about that because it's just creating the function right now. So this will work. And if we call func3, now at this point, now it's going to look at the code inside func3 and execute it. And so at that point, it's going to require func4 to exist. And of course, it works just fine. If we had done this instead, def func, now I'll use 5, def func5, and we'll return func6. If now I call func5 from here and then define func6, which will print running function 6, okay, if we do that, now we get an error because func5 is being evaluated right here. It's being invoked, it's being executed, which means that it needs to execute this line of code. But of course, func6 isn't defined, so now it has a problem. So as you can see, it's okay, and in most modules, that's what happens. You put your functions at the top, and then if you have code that actually runs inside the module, then you put it after all your definitions. But the order in which you put in your definition of your functions in your module, as long as they're not being invoked, doesn't matter. You can, invoke a function before, or you can write a statement that is going to invoke a function before you've actually defined the function itself in the module. That's fine. That will work just fine. So the next thing I want to look at is another way of defining a function. We saw how to define a function using def, but we also have something called a lambda, and we'll take a look at lambdas in a lot more detail later. But for now, let's just see how that works. Lambda is basically something that allows you to create the function, but it doesn't use this syntax here. It doesn't have you define a name for the function at that point. You don't even have to give the function a name. Basically, it's just an expression that's going to create a function for you and return the function, since a function is just, a type like an integer or like a float. It's no different. It's still just a regular object. In fact, we can take a look at type of func6, and we'll see that I don't have func6. Oh, I never defined func6. That was the whole idea. So let's go ahead and look at func5. Okay, it's a function. So it's just another object in memory. In fact, we can even assign that function to another variable. We can say maybe my func equals func5. Well, let's use func4 because I want something that actually works. Okay, so my func equals func4. Now, if I call func4, I get running func4, but I can also call my func because it's the same thing. And so it also says running func4. So as you can see, we can just assign a function to a variable name. That's what def does. Lambda does the same thing than def, but it doesn't assign it a name. You don't have to give it a name. So we'd write something like this, lambda, let's say, and it takes a parameter x, and it's going to return x squared. Okay. And so what did this do? Well, as you can see, it returned a function. So we're going to have to give it a name if we want to be able to use it in this context. In other contexts, you may not do that. You may just pass that as the argument to some other function that needs a function to evaluate. And we'll get into that in detail and see how all that works. That might be confusing For now, I just want to point out that I can say, you know, fn1 is equal to lambda x, and that will return x squared. So now we've given it a name. We've given this thing here, this function, a name called fn1. And now we can call fn1 and we can pass in a parameter of 2 and we get 4 back. So those are lambdas. We'll take a look at lambdas in a lot more detail later on in this course. But what I wanted to point out is that it's just a function, right? Just like def is, and functions are just objects that we can assign to variables and then invoke them by using this parentheses over here. So that's how we invoke the functions. But fn1 itself, it's just that lambda function. All right, so it's no different than a regular function. The thing is, with lambdas, you can't have big code blocks. It kind of has to fit all in one line. Of course, you can do line continuations, that's okay, but it's not meant to replace the def. It's just meant to be for kind of inline anonymous functions that you can pass to another function, because you can pass functions to functions, and we'll see that later on in this course as well. So that's functions in a nutshell, just the basics, and then we'll dig much deeper into them throughout this course. All right. Thanks for watching, and I'll see you in a bit. Hi, in this video we're going to take a look at the while loop. Now the while loop is pretty straightforward. It is something that basically repeats a code of block as long as some expression is true. And so the way it might work very simply, we might have I equals 0 while I is less than 5. Maybe we'll print I. And of course, we need to remember to increment that counter, otherwise we'll have an infinite loop. And so when we run that, you know, it just prints out 0, 1, 2, 3, 4. Now what happens is that it starts off with I equal to 0, and then it tests the condition. Is I less than 5? If yes, if the answer is true, then it will execute this piece of code. And then it goes back to the beginning and it tests the condition again. And it will keep doing that as long as that condition evaluates to true. Once I reaches 5, then we come back to here and we test is 5 less than 5, and the answer is false, and therefore the while loop is now finished. It has exhausted what it needs to do. Now, in the one thing here though is that you'll notice that you're not guaranteed that this code inside the code block will run at all. In fact, if we start with I equal to 5, it doesn't run at all. Well, sure, because 5 less than 5 is false, so it never runs. Now, sometimes you do want your code inside the while loop to always run at least once. And you'll find that you have that possibility in other languages. For example, you have something called the do-while loop. And the do-while loop kind of looks like this. Now, this isn't Python, so this won't work, but you might have, you know, do, and then maybe your code block in here, and then while, and then your expression that you want to evaluate and test for true comes at the end. And so what happens is that this code block executes at least once, and then the test for the loop is done at the end. And if it's true, it goes back to the beginning, runs the code block again. If it's false, it exits out of the loop. Now we don't have that in Python, but it's very easy to emulate that, and we can do something like the following. So we can say, let's say I equals 5, and then we can say while true. So what we do is we're essentially creating an infinite loop here, right? Because true is always going to evaluate to true. So whatever comes inside here is going to run. The code block inside here is going to run, and it's going to run forever, because this is always going to be true. So that's called an infinite loop. Obviously, we don't want that. That's kind of bad. So what we're going to do instead is we're going to use the break statement, and we're going to put our termination clause inside the loop. And we'll write it this way. So while true, it's always going to be true, so it will run. And so this will print 5, then it's going to test to see if I is greater than or equal to 5. And if it is, it's going to break out of the loop. So break is a statement that terminates that loop immediately. It doesn't matter if we put something afterwards here, print, something. This print something here will never run. So let's go ahead and test that out. And as you can see, it printed 5 because, well, it ran the code. Unlike this loop here that didn't print 5 because, well, we never reached it. Here we reached the print statement, then we did the test, then we did the break, and obviously, as you could see, this never ran. Now, where else might you use something like this? Where is that useful? Well, maybe in an example like this. Suppose that we want to use the console to let users enter their name, right? And we just want to make sure that their name is at least 2 characters long, that it contains only printable characters, and that it only contains alphabetic letters. So we don't want numbers mixed in there and things like that. So here's one way that we might want to do it. We might do this. So min length, so I'll make that a variable. That's going to be the minimum length of the name. And then we might do something like this. Name equals input. Please enter your name. And then we're going to say while not, and then what do we want in the not? Well, we want the length of the name to be greater than or equal to the min length, okay? And we want the name to be printable, so we can use this method that's in the string class called isPrintable. And we want to also make sure that it's alphanumeric, so name.isAlpha. And if that is true, so basically if the length of the name is not greater than or equal to the min length, or the name is not printable, or the name is not alpha, right? Because we've got not of this entire thing here. If that's the case, then we're going to want to ask the user to re-enter their name. So when that happens, we're just going to basically take this code here and repeat it. Okay? So we want to repeat that code, and then this loop is essentially going to continue until we have a valid name. But you'll notice that I have to put this name input outside the loop because, well, I need to know what was entered the first time around. And then if it was incorrect, I can ask again and I can go into the loop. So now we can just say print hello name. Okay. And of course that comes after the loop. And so if we run that, we then get asked to enter your name. So okay, I'll type A. It's like, no, that's not valid. Okay, fine, I'll type a number. And something is wrong here. String object has no isAlpha. Yes, I have to kind of spell things correctly. So let's try again. A doesn't work, 12 doesn't work, and if I type my name in, that works fine. Hello, Fred. So the only thing here you'll notice is that we repeated this code, right? I typed the same code in twice. It's really never a good idea to type code twice. You always want to make sure that you only do once whenever you can. And in this case, it's really quite easy to clean up. And the way we would do that, I'm just going to take this code here and we'll refactor it. So I don't want to ask this at this point. But of course, if I do that, I can't make that test. So instead, I'm going to do this infinite loop that we talked about. And then I'm going to ask for the name. So I'll put that up here. And then I'm going to say if the length of the name is greater than or equal to the min length, and the name is printable, and the name is alpha, then we're done, right? We're done with that, so we can break out of the loop. And as you can see, and we'll see when we run it, but this code and this code does the same thing. The only difference is that we didn't have to specify this name equals input twice in our code. So let's go ahead and run it, and we'll get the same thing. So we have A doesn't work, 12 doesn't work, and Fred works just fine. So that's a standard pattern. It's used obviously in other cases than just something like that. This is pretty simplistic, but it's a good example. Now, we also have something called the continue statement. So what the break statement does is that it basically breaks out of the loop and it terminates the loop immediately. The continue statement is a little bit different. Continue means, hey, the current iteration that we're in right now, just skip everything that comes after this continue statement and go back to the beginning of the loop. Rerun the test, and if it's true, continue running. So it's a little bit different. It doesn't terminate the loop, it just stops the iteration, the current iteration. It basically bails out of it right away and continues the loop. So let's look at a simple example. So A equals 0, and we'll loop until a reaches 10, and I'll increment a right away so we don't get an infinite loop. And then we're going to say if a mod 2 equals 0. So if a is divisible by 2, continue. So basically skip whatever comes afterwards in this loop, and all we're going to do afterwards in the loop is just print a out. So if we do that, you'll notice that we just print everything that's not divisible by 2, 1, 3, 5, 7, 9. So this continue did not allow us to continue on to the print statement, but it still allowed the loop to continue. That's why it's called continue. So there's also something kind of interesting with the while loop, is that the while loop can have an else clause. Now we've seen the else clause with an if then else, right? So if something, if, and then we had the else clause. But that's actually also available with the while loop. And the way it works is that the else clause of a while loop will execute if and only if the while loop did not encounter a break statement. So in other words, if the loop ran to its termination normally, say we say that it ran normally, then it will execute the else statement. And that's actually quite useful. Let's suppose that we have the following. So we have L equals 1, 2, 3, and value equals 10. And what we want to do, and by the way, there's much better ways of doing this. I'm just trying to use this example to show you how the else statement works. There's better ways of doing this particular example. We'll see when we get to lists and generators and so on. But for now, here's what we want to do. We want to look at that list L, and if val is not in that list, we want to add it to the list. So let's suppose that we didn't know about the else statement, we don't know what it does. Then typically the way that we'd go about it is to keep track of a flag. Basically that's, and we'll loop through L, and then we'll have this flag, and if we find the value, we'll set the flag to true, otherwise it will remain false. So we have to start with found equals false. So we set the flag. I'm going to use an index to iterate through L. Again, there's much better ways of doing this. So as long as the index is less than the length of L, then we're going to say if L idx equals val, then found equals true. Okay. Now at this point, we don't even need to continue the loop. We found the item in the list. We can just break right away. And otherwise, we're just going to increment the index. And so once this code finishes running, while this loop, when this loop finishes running, either found will be false, which means it has exhausted this loop, or we found the value, in which case found was set to true, and we also terminated early out of the loop. So now at that point, we'd say if not found, L dot append val. And then we'll print L, okay, just to see what the final result is. Now L should be 1, 2, 3 with 10 appended, since it wasn't in there. If we run that, fair enough, that's what we get. Suppose I had put 10 in there, well, that works fine as well. It didn't add it because of that. So that's one way of doing it. But there's a way to do this a little bit better without having to keep track of that flag, basically. And that's by using the else statement. So let's rewrite this that way. So let's say L equals 1, 2, 3, val equals 10. Now we're not going to use found equals false, but we are going to need the index. So we'll set the index equal to 0. And then while idx is less than length of L, we're going to say if L idx equals value. So if we found the value, then what are we going to do? Well, we're just going to break. Okay, that's all we're going to do. We're not going to do anything else. We're just going to break. Otherwise, we're going to increment our index by 1. Now what this means is that we can now write the else clause. And the else clause will only run if the while loop ran without encountering a break statement. In other words, it terminated normally. If it terminated normally, what does that mean? Well, that means we didn't find the value. So at this point, we can say L dot append val. And now we can just go ahead and print L again. And so when we run that, we see that we get 1, 2, 3, 10, 1, 2, 3, 10. we started with 1, 2, 3, 10 wasn't found, we added it in there. Now suppose that 10 was in there. Then you'll notice that, well, it didn't get added as another element. Why? Well, it found it, so it did a break. Because it encountered the break, this else clause that appends did not add it to the list. Okay, so that's how the else statement works. It's kind of weird. You wouldn't expect Python, or you wouldn't expect a loop in general to have an else clause, but the while loop certainly does. And so does the for loop that we'll look at in the next video. But the for loop is a little bit different, and we'll get to that. All right, I think I'll stop there, and I'll break this up into 2 videos. In the next video, what I want to look at is how these breaks and continues that are used inside loops work when you have a try statement inside the loop. So we'll do that in the next video. So thanks for watching, and I'll see you in a bit. Hi, and welcome back. So here we're just going to continue our discussion on the while loop, and in particular, we're going to look at what happens with break and continue when we are inside a try statement inside a loop. And so the question is, what happens? Now, if you remember, with the try, we have try, then we have an except clause that will run when there's an exception, and we can trap specific exceptions. But there's also this finally clause that exists in the try. And this finally clause always runs, even when there's an exception. So whether there is an exception or not, finally always runs. So let's just check that out very quickly, just as a refresher. Let's say we take a equals 10, b equals 1, and we're going to try just dividing a by b. So we're going to say try a by b, and then we're going to catch a 0 division error. Okay, so we'll trap that error, and we'll just print division by 0. And we're also going to put in a finally. And finally, I'm just going to say print this always executes. Okay. So when we run this code, well, there was no exception because b was equal to 1, but we still ran the this always executes. So we see that output right here. Now, if we change b to 0, then we get the division by 0 trap that occurred here, right? So we caught that error and we printed out division by 0. And then the finally also ran as well. So as you can see, finally always runs. But now we might get into the following situation. And let's do a little example. So let's start again with a equal to 0, and let's do another variable b equal 2. And what I'm going to do is I'm going to increment a and decrement b at the same time and do an a divided by b. So if I do this correctly, at some point I'm going to hit a division by 0. When a reaches 2, b is going to reach 0, and we're going to get a division by 0 error. So I'm going to do that inside a while loop. So won't run the while loop for too much, just enough to get to the error and one more. So let's do a less than 3. In fact, I'll do a less than 4, just to be sure. And then we'll print. First thing I'm going to do is just print some dashes out just to indicate the beginning of the loop so we can keep things kind of neatly separated as we're printing. And we'll set a equal to a plus 1, right? So we're incrementing a by 1, and we're going to decrement b by 1 as well. So basically, at some point, b is going to become 0. And then we're going to do our try. So let's go ahead and do a try. And we're going to say result equals, actually we don't even do result, we're going to just try a divided by b. Not going to store that anywhere. And we'll do except our 0 division error. And when we have a division error, we're going to print out the 2 numbers that are causing the problem. And we'll say that this is in the division by 0. Okay? And then we'll just format a comma b. So we'll see what's causing the problem there. And what we're going to do now is we're going to say continue. So if we get a division, if we run the exception, let's do a continue. Let's just go ahead and do that, and let's see what happens. So in this case, I'm putting the continue inside the except clause, but you could put it inside the try as well. It doesn't matter. The finally will still run. And let's go ahead and print the finally. So we'll do print let's print the values out again. And let's just say this always executes. Okay, so this is in there, and we need to format it with A and B. Okay, and then I'm going to put something in the main loop. I'm going to put in, and I'm just going to do the same thing basically. I'm going to print out A comma B. And we'll say that this is in the main loop. So now we should be able to identify every print statement, where it's coming from, and see what's going on as this thing runs. Okay, and that's it. So basically we've got this while loop. We're incrementing A, decrementing B. We try dividing A by B. If we have a zero division error, we trap it. We print out this thing, and then we do continue, which will basically go back, remember, now to the beginning of the loop and re-execute the test. But it will not reach this point. When we have continue, it will not reach this point. If we don't have an exception, then it won't continue, and we will reach this point here. So let's go ahead and see what happens when we run this. And of course, that's not what I expected. I've got an unexpected that. Okay, so I typed in something incorrectly. Right? I knew I was going to get an exception, but I wasn't trapping that one. So let's try it again. Okay, what am I doing wrong? Oh, I really can't type, can I? All right, let's make sure. Yeah, everything else looks fine. Okay, now we got it. All right, so let's see what happened. And, all right, I still can't type. I'm going to leave this in the video so you can see kind of the errors and, you know, maybe how to start debugging and understanding sometimes some of the stuff that comes back. So here's the error. I have my try, my except zero division error, and it tells me that I errored out on this line of code with a zero division error. Well, that's what I'm trying to trap. Why didn't it trap it? Well, the only reason would be if I'm not trapping the correct error. And let's see what I'm trying to trap. I'm trying to trap zero division error, but I misspelled error. It's 2 R's there and only 1 R there. So I wasn't trapping the Python zero division error. That's why I actually got a zero division error in here. Okay. All right, so let's try this again. Much better. It was supposed to execute without actually creating an exception at runtime. So we'll see 1, 1. So it executed 1, 1. It always executes. That was the finally. Okay. And then it printed that from the main loop. Then we started the next loop. We have 2, 0. Look what happened. We printed out division by 0 right here. So we reached that line of code. That line here reached, or was reached by this, was generated by this line of code. At this point, we did a continue. But look at what happens. The 2, 0 still gets printed with the always executes. So the finally code block actually executed, even though we have the continue here. And that will always happen. So if you're inside a try statement and you have a continue, and if you have a finally, the finally will execute. So that's great. That means that, you know, if you need to make sure that you close a file or close a database connection for some reason, you know, maybe roll back a transaction or do something when the, you know, after you're done trying to deal with whatever it is in that particular loop iteration, then you're assured that the finally will run whether you had an exception or not. We know that. But even if you have a continue in there, let's say in your exception trap, it will still run the finally. It's not going to bail out of the loop until it's executed the finally, and then it will bail out. So that's really good to know. Now this works with break as well, not just continue. So if we take this, and now I know at least it executes correctly, and all I need to do, let's see if I can spell this, break, okay, then of course what's going to happen is that we're not going to get these iterations because we're going to break as soon as we hit the first error. So if we execute this, as you can see, we again, the finally executes, right, because this division by 0 error occurred, we still executed the finally, and then we did the break on the statement. Now, of course, you could also combine this with the else clause if you want, right? So now we could say else, and of course, when will the else execute? If the break was never encountered, which means what? We never had a division error, a zero division error. So we can just say here, print code executed without a zero division error, right? So we know that that's the case if we reach the else clause. So when we do that, we don't get this print statement. We don't get the string printed out. Why? Well, we had a division by zero error. So let's tweak this so that we don't get a division by zero error. All I need to do, if a is going to run up to 4, I'm going to make b, let's say, equal to 10. So as b gets decremented, I know that 10 minus 4 isn't going to become 0. So if we run that, then you'll notice we get all these loops, and then we get code executed without a zero division error. So it did, in fact, execute that else statement. All right, I think that kind of sums it up for the refresher on the while loop. So remember, the while loop, you start and you always evaluate the conditional expression first, which doesn't guarantee that your loop will run at least once. If you need to do that, you can use the while true kind of approach. The while loop also has an else clause that can be attached to it, which executes if and only if the while loop terminated normally, i.e. without a break statement. And then the continue and break statements can be used inside a try statement inside a loop, and the finally will always still execute before either breaking or continuing from that point forward. All right, so thanks for watching, and I'll see you in the next video. Hi, in this video we're going to take a quick look at the for loop. Now, I want to first of all discuss the for loop in other languages in case you've actually used them before and run across them in languages like C or C#, Java, and so on in JavaScript, because this is kind of the way that for loops might be written. So for, then you declare some kind of loop variable maybe, and you start it at some initial value. So that is code that will run one time before the loop starts executing. Next, you have the condition for the loop to continue executing. So you might have, let's say, I is less than 5. So every time that the loop finishes its code block, it goes back to the beginning and it checks that condition. If that condition is true, it will then execute the for loop again. And then finally, we have a piece of code that gets run at the end of every iteration. So very often, this is how it's kind of written. And then you have your code block in here, and, that is your loop. So that's how for loops work in many other languages, in C-style languages. But of course, that's not at all the same in Python. The Python for loop in this kind of state doesn't exist. There is no such thing. So before we get to that, I want to then define something called an iterable. Now, an iterable, and I'll just put in this definition right here, it's in the notebook that you can download, but an iterable is an object capable of returning values one at a time. So an iterable, and please note, I didn't say that an iterable was a collection of values that could be returned one at a time. I just said an iterable is an object capable of returning values one at a time. And we'll see what that means when we start looking into things like iterators and generators later in this course. But it's not quite the same thing as a just list of stuff. Now, lists are iterables, right? So we have lots of objects in Python that are iterable. Tuples are iterable, strings are iterable, and many others. So let me go back to this piece of code right here, because I just want to show you that although we don't have this, this is something that basically just does repetition. The for loop is something that will allow us to iterate over an iterable. So it will basically go and get the next value, as it's running the loop, which is not the same thing as this thing over here. Now we can write this equivalently in Python, and the way to do it is to use the while loop. So the while loop is probably the closest thing that you'll find to the for loop of these other C-style languages, which also have a while loop too. And in fact, in those languages, you can always rewrite a for loop as a while loop, because it really just means that it does certain things. So if I wanted to rewrite this over here, specifically in Python, then I would write it this way, I equals 0. Then the next thing is we have to do a while loop, and we want to continue running as long as I is less than 5. Okay, so here we go. Now we need to do our code block. I'm just going to print I. Okay, Now the next thing is that this is the piece of code that runs after the end of each iteration. Well, that's what we have to do here. We have to increment I. Now, we don't have a plus plus operator in Python, but we can write it as I plus equals 1. Now the only difference is that once this for loop has finished executing, the I variable goes out of scope. It goes away, basically. It gets discounted. And so we can do the same thing. We can just say I equals none. Now, you'll see that later on when we take a look at memory and memory references, you'll see that we don't actually need to do this. This will actually get done for us automatically, and in certain cases, actually, this will not even help. So, you know, you run this is it. So we have the same for loop. But of course, that's not what the for statement is in Python. It is something to iterate over an iterable. Now, an iterable, a very simple iterable that you can create is by using the range function. So you've probably seen this before. For I in range, let's say 5, and then we'll print I. And there we go, 0, 1, 2, 3, 4. So you might think that, hey, this is exactly the same as this over here. It's not. Again, this for loop was in fact run using code that looks like this. This is different. This is using an iterable object, range 5, which is iterable. And when it runs its loop, it just basically calls the next, it asks this object here for the next value, and then it puts that value in I, and then we have that value available in the loop. Now in languages like Java, you have the for each, right? For x in some object collection. So if you've done Java before and you're aware of that, this is more what the for in Python does. It basically iterates an iterable. And I'm not saying a collection, just an iterable. Range is not a collection. Range is not a list. And we'll take a much closer look at all that in detail later on in this course. Of course, lots of other objects are iterable as well. So for I in range, we're not going to use range. Let's say we use a list, right? So we can do 1, 2, 3, 4. And we can say print I. And again, here we go. We've printed that. We can say for C in hello. So a string is just iterable. We can get each character one by one. There we go. For C in hello, we get the string. And so on. You can even use tuples. Tuples are iterable as well. So for X in A, B, C. So I've got a tuple that contains, and let's throw in a number just for good measure. And we can print X, and we just get the individual elements of the tuple. Now, of course, you can also have more complex objects listed in an iterable type. So for example, you might have for X in, and here I'm going to do a list containing tuples. So let's say 1, 2, 3, 4, 5, 6. Right? So this list contains tuples. And when we print X, you'll see that we actually get the tuples back. Now, of course, we can unpack the tuple. We might say I, j. So it's going to take each tuple, and it's going to take the first element of the tuple, put it in I, take the second element of the tuple, and put it in j. So now we can do things like this. And we actually, as you can see, we were extracting the individual elements of each tuple that was returned every time that the next object was requested in the for loop. So we'll take a look at that in a lot more detail as well later on. Now the break and the continue statements work just the same as with the while loop. So if we have something like for I in range 5, if I equals, let's say 3, we'll continue, and otherwise we'll print I. Okay, so basically this should skip when I equals 3, and there we go, 0, 1, 2, it skipped 3, but it still continued running the loop. Now we can take the same thing, and instead of doing continue, if we do break, then you'll notice that we stopped, right? So we exited the loop at that point. So we stopped iterating at that point. Okay, now you also have the else clause. So we can do something like this. For I in range, and I'll start at 1 and end at 4, and we'll print I just to see what's going on, and then we'll do this. If I mod, let's say 7 equals 0, print multiple of 7 found. Okay? And what we'll do here is we'll break. So we're going to exit out of the loop. So once we hit the first multiple of 7, we'll break out of the loop. Okay? Now, in this case, are we going to hit the multiple of 7? Well, no, because we're going to have really, we're going to be iterating over the numbers 2, 3, and 4. So that's never going to happen. So let's put in a break, an else statement. And, well, what's going to happen if to reach the else statement? How does that get reached? Well, it only gets reached if we never hit the break. So it means we didn't find a multiple of 7. So we can just write no multiples of 7 in the range. Okay? Something like that. So if we run this, you'll see that we are printing out all the numbers here. 1, 2, 3, 4. And we exhausted the loop, right? We ran through this range, 1 through 5. So 1 through 4 inclusive. And we didn't find a multiple of 7, so the else ran. Now if we make this a little larger, let's go to 8 so that we include 7 in there, then you'll see that we found a multiple of 7. Now of course there's better ways of actually finding, if we have a multiple of 7 in a range, but this is good enough as an example of the break and the else and how they work together. Also, if you use a try-catch inside the for loop, it works exactly the same way as with the where clause. The finally statement will execute whether you put break or continue inside your try or catch statements. The finally will still execute if those get encountered. So let's take a look at a quick example for I in range. Let's do again range 5. And we're just going to print out some characters to indicate the beginning of the loop so we can see what's going on. And we're going to try doing this. We're going to try 10 divided by I minus 3. So when I is 3, we're going to hit a problem. We're going to have a division by 0 error. So we're going to catch that. So we're going to say except 0 division. Let's make sure I spell error correctly this time. And we'll print divided by 0. Okay? And we're going to continue the loop. We're not going to break out of it, but we're going to stop that current iteration and move on to the next one. We don't want to deal with, when we have a value of I that's going to cause a division by 0. And then we want to do something, though. We're going to put the finally in. Now, all this is kind of, not exactly practical code, but it's good to illustrate what's happening. So finally, it's just going to print always run. You're probably not going to write anything like that in your code. You're going to do something that handles, maybe closing a connection, maybe handle some open transactions, whatever it is, you can put in there. Okay, and then we're going to print I in the main body of the block, of the loop block. Okay, so if we run this, let's see what happens. So you'll notice that no error happened here. So we printed the beginning of the loop, right? This was the print, the beginning of the iteration. We didn't get a division by 0 error, and then finally ran. Same thing with when I was, and then we printed I, which was 0. Then we did the same thing again. So we start the loop again, we print always run, we print I, which was 1, etc. When we hit 0, then look what happened, right? We printed, first of all, the beginning of the loop, right here. Then we printed divided by 0 right here. Now we put a continue in here. So technically, we should have gone immediately to the beginning of the next loop. But that didn't happen. What first happened is that we printed always run. And then we went to the beginning of the next loop. There are a standard number of techniques that you can use to iterate over iterables. So the standard one, which we saw just now, is this one, for C in S, and then we print C. And so we get that. What you don't get here is the index if you're talking about a iterable that is indexable, right? That has indexes. For example, a string or a list or a tuple. All these are iterables that also have an index. You can talk about the first element and the second element and the third element. You can talk about that. When you talk about sets, well, sets, and we'll see all this later in detail, but sets are iterable, or dictionaries. They're iterable, but they don't have an index. You can't talk about the first element of the set or the first element of the dictionary. There is no concept of first and last. There is no ordering of objects inside a set or inside a dictionary. But they are still iterable. You can still, start somewhere and then just call next to get the next thing. But we'll see how it works exactly with sets and dictionaries. It's a little different because dictionaries have keys and values, and the keys actually are iterable and the values can be iterable. And then you can also iterate over the key value pairs, but it works just a little differently. But it's still iterable using a for loop. This is a little different. This has an index, right? We can say that H is at index 0 and 1 is at index 1 and so on. So we want to be able to get the index back. So you might be tempted to write something like this. Right? So we have s equals hello, I equals 0 for C and S. So now we're going to iterate C over S. And we're going to print this I, which is going to be our index. And we know we start at 0. So our first index will be 0. We'll print the character and then we'll increment I. So when we do this, we get, 0, H, 1 was E, 2 is L, 3 is L, 4 is O. Okay, so that works. I mean, there's nothing wrong with this piece of code. But you have something that you can use that might be a little simpler, which is to just use indexing. So you might do something like this instead. Let's try again, s equals hello. And here we're going to say for I in, and here we're going to use a range. And we're going to range over what? Well, we're going to range from 0 to the length of the string s minus 1. The last index will be the len of s minus 1, right? So the range will be from 0 to len s minus 1, because as we know, the high number here in the range is not inclusive. Okay, so if we do that, we can then print I and si. So that's another way of doing it. If we run this, we get the exact same thing. That's just another way of doing that. But there's an even better way that we can use. Now again, I'm not saying this is wrong. It is not. It's perfectly fine code. It's fine. This as well. This code works. But it might be a little easier to write and understand what's going on here. For I comma C in, and we're going to use a special function in Python called enumerate. That can work, and it will actually return the index and the element. So it's going to basically do this kind of thing that we did here manually, and here it's just going to do that for us. So it's just a little cleaner. And here we can print I comma C, and enumerate returns a tuple. The tuple, the first element of the tuple is the index. The second element of the tuple is the actual value that we're getting back from the iteration. And so we can store that into two local variables. And when we do that, we get the same thing. So that's the enumerate function. Very handy. And it saves you having to write this kind of code over here, which, although perfectly fine, this is a little simpler. It's also quicker to read and easier to understand what's going on. Okay, you're enumerating S. Here, I'd have to say, okay, you're declaring, I equal to 0, and then you're just incrementing. Okay, so that's the index. Yeah, you have to read the code a little bit and spend some time understanding what it does. Whereas this is immediately obvious what you're doing because it's a standard function and we know what it does. All right, thanks for watching, and I'll see you in the next video. Hi. In this video, we're going to take a brief look at classes in Python. Now, this is a subject that we'll come back to in a lot of detail in the object-oriented section of the course, but I just want to show you some basic things about classes in Python. You should already know about object-oriented programming, so a lot of the concepts that I'm going to show here should already be familiar, but I want to make sure that you also know how to do it in Python. And we'll keep it quite simple. So, let's say that we want to create a class. To do so in Python, we use the class keyword. So we're going to define a class using class. So let's go ahead and create a rectangle class. And now we want our initializer. Now the initializer in Python is called, or is implemented using this dunder init method. Now the dunder init method is actually a method that runs once the object has been created. So there's actually two steps when we create an instance of our rectangle class. We first have this new step. If you come from Java, you know about new. So we've got the same thing in Python, but then the initializer is a step after that. After the object's been created, then we can go on to the initialization phase. So what happens in Python with these instance methods is that the first argument of the method is the object itself. So our first argument is going to be the object. We typically call it self. You can call it anything you want, right? You can say, you know, new object that was just created, right? You could do something like this. So this would be the first argument. But it's customary and you should use self because everybody knows what that means. So self means the instance that was just created. And then in addition to this, in the init method, we're going to require the width and the height. And so now we're going to set properties, attributes of the class. In this case, they're going to be value attributes, so we call them properties as opposed to methods, which are callables essentially. So this attribute is going to be called width. So we're going to say self.width. So we're going to say this object that was just created, that's called self, that's what gets passed into this first argument. Python does that for us. We don't have to worry about doing that. So self.width equals width and self.height equals height. And I know if you come from a Java background, you're probably kind of screaming right now saying there's no data encapsulation going on. And you'll see why it actually doesn't matter in Python. So let's go ahead and create this class. So now there we go. We have our class and we can create an instance of that class. Let's say a width of 10, height of 20. And now we can query the width. There we go. We can set the width. Okay. And then we can query the width again. And we see that we have that. So that's great. Okay. We were able to create a very simple class with two properties, width and height. So the next thing we're going to look at is adding attributes that are actually callables or methods. So I'm just going to copy paste. And let's go ahead and add an area method. So area. Now area is an instance method. It's going to need to receive the object that we are working on. So again, we just use this self. So here, what do we want to do? We want to return self.width times self.height. Okay. And let's go ahead and do a perimeter as well. Perimeter, self again. And then here we're going to return 2 times self.width plus self.height. Okay. So now we have a class that has 2 properties, width and height, and 2 methods, area and perimeter. They're basically just functions, but they're special functions because they get called using that dot notation. So for example, let's say we do this, 10, 20. Now we can again call width and height, but here I'm going to call area. Now area is a callable, so I need to make sure it gets called. It doesn't require any arguments other than this object. So why am I not putting it in here? Well, it's actually over here. When I say r1.area, what Python does, it calls this method area that's in the rectangle class, and it takes r1 and passes that as the argument that we've called self here. So again, this doesn't have to be called self. It could be called, you know, something. So I'm just going to show you. This is a terrible idea, but I'll just show you that this will work just equally well. So let's go ahead and rerun that, redefine our object. So now we can call the area, and we get indeed 10 times 20, which is 200. And we can call r1.perimeter. And we indeed get 60. So as you can see, that worked just fine. However, let's just go back and let's call this self. Okay, this is the traditional way of doing it, and that's the way you should do it too. And why? Not because you have to. Python doesn't care. It's other readers of your code. If they see something else than perimeter here, then self here, they may be thinking there's something going on that's different, because we have other kinds of things that we can do. We can have class methods, we can have static methods. So if you don't call it self, it's not immediately, visible that this is just an instance attribute. So be careful with that. Just stick to the conventions on that one. So now we've seen with various objects in Python that they have string representations, right? You can usually print your object out, like an integer or a fraction or decimals and so on. They have string representations, lists as well. So what about our class? Well, let's go ahead. Let's say, let me make sure I rerun all this. And let's go ahead and look at string of R1. And we get this thing over here that says we have a rectangle object in our main. This is the module we're in. It's the main module at some memory address. So this is the memory address of R1. In fact, we can do hex of ID of R1. You'll see that it's the same address, 936A0 and all that stuff in front. Okay, so that's obviously not what we want. We'd like probably, a little bit better representation. Like, for example, saying, well, it's a rectangle with this width and this height. That might be something we want to do. So this is done. We can just create basically using a method, right? So let's go ahead and I'm going to copy this code, paste it over here, and let's add a method. Let's say def, and let's call it toString. If you come from the Java world, you know what this is. We can call the toString method to get the string representation. What do we want to do? Well, we're going to return, let's say, we're going to call this is a rectangle, and we're going to say the width equals the width, and the height equals, if I can type, equals the height. Okay, and then we'll format this with self.width and self.height. Okay, so now let's go ahead and create another rectangle. Let's say 1020. Let me shift that over. And now I can call string R1. That still brings that out, right? This thing over here. Why? Because we need to call toString. So what we really need to do is to say R1 toString. Okay? So that kind of, that stinks, because we can't use this, which is the traditional way of doing it with the built-in classes. But this is where we can really take advantage of the way Python goes about allowing us to overload this thing, to basically define what does str mean. Str by default, is just going to look at the class and the memory address of the object. So how do we override this essentially and provide our own definition for str? Well, it's very simple. We have these special methods that Python has. Now, people call them magic methods, but there's nothing magical about it. They're well documented and they're well known, right? So they're not magical. They're not hidden or anything like that. It's not, a black box. So the special method name that we have to use here is called dunder str. So dunder means double underscore, double underscore. Okay, so dunder str. And if we do this, now we can just rerun this code, and now you'll notice that when we run str of R1, when we call the str, the built-in str function on our object, which is a custom class, we get that string representation. Now, if we just do R1, and this is kind of specific now to Jupyter Notebook and to the Python interpreter. If you're running, let's say, in a Python console, and you just call the object this way, or what happens is that it's still going to return this. Now, that's not the functionality we get if we have a list. Let's say we have a list, 1, 2, 3, right? We can convert list to a string. We get this, right? That's the string representation. Or we can also just do this. We can say L, and then we get this representation here. You'll notice it's not telling us, hey, this is a list at some address. So what's happening is that it's a different special method that we need to implement. And we'll get back to this one in a lot of detail as well. But for now, it's called R-E-P-R, repr. It's basically representation. And the representation typically is, if it's possible, a string that shows how you would build the object up again. Now, in some cases, there's too many variables, you can't do it, but in this case, we can, so we're going to choose that. So how did we actually instantiate this object? Well, we called rectangle, and we passed in two parameters. We passed in the width and the height. So let's go ahead and create that. So now I'm going to run it again. Now our string representation hasn't changed. Still says rectangle with width is 10, height is 10. But now if I do it this way, you'll notice that I have rectangle 1020. And so what comes out here, this string, if I was to execute it, it would actually create a rectangle with width 10 and 20. So that's what the representation is used for. So now how about equality? Let's say that we have this rectangle R1, and let's say we have R2 equals rectangle, and we'll make it the same. So R1 and R2 are basically the same rectangle. But you'll notice that R1 is not R2, right? They're different memory addresses, they're different objects, different instances of the class. But if we do R1 equals R2, we get false. Now we really would expect that, you know, as a user of rectangle, if it's got the same width and height, it's the same thing, it's the same value, right? The object might be different, but it's the same value. So how can we do that? Well, that's very simple. We have again a special method in Python, which is the dunder EQ method. That allows us to basically specify and define how we can compare our objects to each other. So let's go ahead and implement that. Again, I'm just going to copy this code, paste it over here, and we're going to basically keep going. So we're going to implement this dunder EQ method. Now, the dunder EQ method is an instance method. It's going to take self. If you look at this line of code, R1 equals R2, then there's actually two objects, right? We're comparing two objects. So R1 is actually going to get passed into the self argument, and R2 is going to be the other argument. So we're just going to call it others, the other object. Now I'm going to keep this simple initially, but we will need to add a little bit more to make it more complete. So for now, what do we want? Well, we want to say two rectangles are equal if their width and height are the same. So let's go ahead and maybe write it this way. Is equal. Actually, we're just going to return it. So we're going to return self.width equals other.width. We want to make sure the width is the same, and self.height equals other.height. So we can do it this way. If you're used to tuples, you could also actually do it this way. You could say self.width, comma, self.height. This tuple should be equal to the other.width and other.height. Okay, we could do it this way as well. However you want to do it, I think this one is probably a little bit more expressive. You know, self.width equals other.width and self.height equals other.height. I tend to prefer this, but up to you. So now let's just make sure this works. Let's go ahead and create a rectangle of size 10 and 20, and let's do another one. Okay. Now R1 is not R2. That's still true. They're different objects. However, R1 is equal to R2 using the equality, because in terms of values, they are the same. Now, there is one problem though. Let's say I say R1 equals 100. Okay. We have this problem here. The int object has no attribute width. Well, yeah, what happened is that this equal method was run, and we're trying to get other.width and other.height. Well, integers don't have those properties. So we need to fix that. And let me go again, just copy paste. Let's fix this up. And what we really want to make sure is that other is an instance of rectangle. Now we'll get into that in later sections, but I'm not going to use type. type is too restrictive. If I use type, I can find the type of other, and it will tell me if it's a rectangle. But what it doesn't handle is if I've subclass rectangle, and now I want to use the equal method. If I check the type here to be specifically a rectangle, it's not going to work with subclasses. So in this case, what I'm going to do is I'm going to say if is instance. So instance will work with subclasses. And what is that? Well, I want to make sure that other is an instance of rectangle. Okay, that's one way of doing it. Or I could use the class property of self, but in this of other. But in this case, of self. But in this case, I'm just going to hardcode it to rectangle because I'm not really looking for it to be anything else. And if I subclass it, this is still going to be correct because isInstance is still going to do that correctly. So if I have an instance of a rectangle, do this. Else, you have to return the not implemented value. Actually, no, we're going to return false. Okay? We're just going to say that if you're trying to compare a rectangle to something other than a rectangle, they can't compare equal. That's always going to be false. Okay? So we'll go ahead and write it this way. So this is now a little cleaner. And we can go ahead and create our two rectangles again. I'll copy paste that. And then R1 equals R2. That still works. And now if we say R1 equals 100, we get a false, which is true, right? That's the correct answer. R1 is not equal to 100. Now, what about methods like comparisons, like less than? So operators like less than, greater than, less than or equal to. Well, we also have special methods we can use to implement those. They're methods like dunder LT for less than, dunder LE for less than or equal, dunder GT for greater than, dunder NE for not equal, and so on. And these are all well documented. So let's just go ahead and write one. So again, I'm going to take this code, copy paste, and let's implement the less than. Okay, so let's implement less than. And again, we have two, right? The less than operator is a binary operator. It has two operands. So we need self, which is going to be the left-hand operand, and then other, which is going to be the right-hand operand. So let's go ahead and implement that. When is a rectangle smaller than another one? We're going to do it based on the area. Now again, it's up to you as the writer of the class to define how you want to define, ordering in your rectangles. I'm just choosing to do area. So again, though, I'm going to have to check the instance. I don't want to try and compare a rectangle to, an integer. So I want to make sure that other is an instance of rectangle. And I'm going to return here that self.area is less than other.area. Okay, that's all I need to do. I need to make sure that the area of myself is less than the area of the other. Okay, whatever this computes to will tell me if it's less than or not. And if it's not, now here we don't return false, right? But logically here, what I really want is something else. So instead, I'm going to return the not implemented value. We'll get to this later, but we don't raise an exception. We just return not implemented. This is a little different. Okay, so now we have that. Let me go ahead and copy paste these two. But now I'm going to make 100 and 200. So obviously R1's area is less than R2. So now I could say R1 is less than R2. And name instance is not defined. What have I done? If is instance. Sorry. Okay, if is instance. Just like I had over here. So let's rerun this. R1 is less than R2. As you can see now, actually returns true. So we implemented less than. So R2 is also a rectangle. So we could say R2 less than R1, obviously, and that's false. What about R2 greater than R1? We haven't implemented greater than, but if you look at what happens, it returns true. And that's because what happens is that with R2, Python called the dunder GT method, greater than. It wasn't implemented. So what it does for us, it basically flips this around and says, okay, well, if R2 is not greater than R1 is not implemented, how about R1 less than R2? And in this case, well, R1 less than R2, that less than is implemented, so it worked. But obviously, you're not going to get things like R1 less than or equal to R2. That is not implemented. Okay, so it says it's not supported. We would have to implement those ourselves. Now I want to look at these properties that we had, width and height. And let's go back to a slightly simpler version of the class. So we have class rectangle. Let's go ahead and put that in. I'm just going to take out area and perimeter just to simplify the code a little bit. Okay, so we have this class, and we saw we can basically say a rectangle 10, 20, right? And then we can look at r1.width. Okay, it tells us what the width is. We can set the width as well. We can say r1.width equals, let's say, -100. Okay, and now if we look at r1.width, well, that's -100. In fact, r1 we can see has a width of -100, and its height is still 20. So a few things going on here. One is that we're allowing direct access to the width property and the height as well, but I'll focus on width. Which means that, in particular, users can set this to -100. And we may want to put logic in here that stops people from setting the width to a negative value. It doesn't make sense to have a rectangle with a negative width or height. It needs to be positive. Even 0 doesn't make much sense. So the way you do that in languages like Java, for example, and in Python as well, is we implement methods to get and set the properties. So what do I mean by getter and setter methods? Well, let me show you. Let's say we write a getter method. So basically, I'm just going to say get width. And here we're just going to return self._width. Well, self.width. So the first thing I'm going to do here is make width and height private variables. We don't have private variables, true private variables in Python. There is no such thing. So instead, this is a convention. If we put an underscore in front of our variable names, in front of our properties, basically we're telling, and same thing with the methods too, by the way, we're telling other users of our class that, hey, this is a private variable. Please don't touch it. Don't modify it. Don't mess around with it. But of course, if they want to, they can. If something blows up, that's their problem. That's their fault. But it's still possible to change it. Now, it might be in some cases that you have, a user of your class that knows exactly what's going on, and there may be a reason why they want to change that attribute directly. Here, what we want to do is we want to encourage people to not use width and height directly, but instead to use the getters and setters. So we might do it this way. Let's go ahead and write the get width. So we start with _width _height. And now, okay, well, first of all, with the string, and I'm not going to put it here, I'm going to put it above. But let's just fix the string and all these things first, because you'll notice that they're using self.width. Okay, well, in this case, I'm going to use the internal, that's _width and height. I'm going to do the same thing here. Right, we have to do that here, and I have to do that here as well. Now, I've got to be careful here. I mean, I can still do this, so let's go ahead and do that. And I'll come back to this and explain why you got to be a little careful here. But let's first get this going. So I've got all this self_width and self_height. So I fixed up my class. Okay, I had to make all these changes because I changed what this was. Now, what I want to do is I want to implement a getter and a setter method. So let's say get width self. So we'll just return self._width. So basically, this get width function does nothing more than just return the width. Okay, and then we have set width self width. And here, we want to do something a little bit different. We want to stop people from putting in negative values. And I'm also going to, not allow 0 values. So I only want positive. So I'm going to say if width is less than or equal to 0, I'm going to raise a value error. I'm going to say width must be positive. Okay. Otherwise, I'm going to say self._width equals width. So basically now I have a method that I have to call to set the width. And I'm going to copy paste those and do the same thing with height. Actually, you know what? Let me leave out the height just for a minute, okay? So let's just work with the width. Okay, so now I have this class that has private, pseudo-private variables, width and height. Pseudo-private properties, instance properties, width and height. So now I can create my rectangle. If I try and read the width, I have an attribute error. It has no width. Now this one is going to be a little odd. If I run this, you'll notice that no error happens. Now we'll get back to this later in the course, but this is called monkey patching. Essentially what I've done is I've added a property called width to R1. But I've done this at runtime, and Python allows us to do that. So there's a lot of problems going on here. The width, it's still, you know, this width property is negative 100, but the underscore width is still 10, right? It was created as 10, 20. In fact, if we print out R1, we have 10, 20. So there's a lot of things going on here in that now the person said R1.width, and that created a new property. We also now are able to say R1.getWidth, and that's the way that people should be accessing the width, not the underscore width. They should be accessing it using getWidth. And to set the width, now we have to use the setWidth property, and we can say set it to, let's say, -10. Now you'll notice what happens now is that we have a value error. The width must be positive. That's exactly what we wanted. So now we can say set width, let's say, to 100, and that now worked correctly. In fact, we can see the width is 100. But you'll notice what happened is that if we had released this class, you know, a while back, and we had it the way we originally had it, then people all over the place were using R1.width to read and to set the property. You know, maybe we were using our rectangle class all over our code, or maybe a coworker, we're working in a team. Other people are using it. And now I go back and I say, well, no, you can't do that anymore. You have to use this get and set methods. Well, that just broke everybody's code. So in Java, we usually don't start with the, you know, what we had before, with the bare properties. Instead, we always write getters and setters from the get-go. And very often the getters and setters are nothing more than something like this. We don't even have the rest of that code here. We start with that. And what this means is that if we now have to put in logic like this, we go ahead and put it into the set width, and it hasn't broken anybody's code. So that's one of the main reasons why, you know, you do this. You set up your encapsulation this way so that you can have control over how you get and set the properties. I'm not even going to talk about calculated properties. For now, I'm just talking about actual physical, you know, concrete properties. So that's the typical way of doing it if you come from a Java background. You don't start with this, okay? So let me show you why in Python it doesn't actually matter. So I'm going to keep this, but I'm going to copy paste the code, and I'm going to show you the Pythonic way of doing this. So I'm not going to implement these things over here. I'm going to go back to the original class that we had, okay? So I'm going to go back to this. I'm going to remove the width, the underscore, okay? I'm going to remove the underscore. I'm going to remove the underscore here, and here, and here, and here, and here. Okay. So now I've gone back to my original class. So I can say R1 equals rectangle 10, 20. I can read the width. I can set the width. I can set it to a negative value. And I can look at R1. It tells me, okay. All right, so this is what we had before. That's what we, you know, released, let's say. And now we realize that, well, we really want to stop people from setting the width to -100. So what's the solution to that? Well, the solution is exactly what I showed you before. It's writing a setter and getter. But we want to do this without being, you know, without breaking our backward compatibility. And Python allows us to do that. And that's the reason why you don't have to start with getters and setters right away for variables. So in Python, unless you know that you have a specific reason to actually implement a specific getter or setter that has extra logic, you don't implement them. You just leave the properties bare that way. That's perfectly fine. First of all, there's no such thing as private variable, so anyway people can modify it directly. And secondly is, don't force people to use a getter and setter unless they have to. And really what happens in Python is that they're not even aware that they're going to be using a getter and setter if we implement those. It's going to be transparent. But Python is going to have to go through and actually run a method instead of being able to access width directly. So if it doesn't have to do that, it'll be a little more efficient. How do we go about doing this? Well, we're going to write a function, basically an instance method that is going to return the width. That's going to be our getter. But what we do is we use these decorators. And so we use the special syntax. We'll use the at property, and we'll get into what decorators are later. For now, I'm just going to use it. And we're going to call it width. So now this is a method called width. So here, what I'm going to do is I'm going to go back to using the underscore width. And I'm going to go back to using the underscore height. Okay? This means that I have to fix things up over here. Self.width, self.height. Well, maybe not. Let's see why not. I'm going to leave that code as is for now. And let's go ahead and just finish up writing the properties. So I'm going to write a getter for width. This is what this is going to now enable me to do. It's saying, okay, this function that comes after here is a property. So it's going to be called width, and it's just going to return self.underscore width. And then I'm going to do the same thing with height. Height, self. I'm going to return self.underscore height. Okay? And let me go ahead and run that class. So now I can go ahead and create this new rectangle, and I can read the width. You'll notice that worked. But what did it run? It actually ran this function. Let me just show you. I'll put a side effect. Never a good idea to do that. But width, let's call it, let's say getting width. Okay? And then we run it again, and you'll see it's printing out getting width. It went through the width method. But you'll notice how I accessed it. There wasn't a call here. I didn't say r1.width parentheses. Basically, because I used this property here, Python now is able to access the width via the getter, and I didn't have to change any code that was actually using .width as the direct access to the property before. So I now have a property that goes through a method for the getter without breaking backward compatibility. This is why you don't have to do this right off the bat, and you shouldn't do that right off the bat. You should only do that if you need to. In this case, I need to because I want to stop people from setting width and height to a non-positive value. So I've got that for the width, I have that for the height, but of course if I try and set the property, that's not going to work because I don't have a setter. So now I need to write a setter. So let's go ahead and write the setter. How do we write a setter? Again, we have to use a decorator, and so here the way the decorator works is we have this width property. So we start with the width and then we say dot setter. And you'll see how all this works when we deal with decorators and classes later on in this course. So the width.setter, the name of the method is actually the same. Okay, now don't be confused. We do not have overloading in Python. Okay, you don't have overloaded methods, this way. Don't think that this is like other object-oriented languages where since we have now the width that we need to pass in, you could say, well, this is a different signature than this one, so it's two separate functions. It doesn't work that way in Python. We don't have that, and we'll see that later. But the reason why this is okay is because this actually modified what this function is. So this function and this function are not stepping on each other's toes. All right, but anyways, this is how we do it. And then here, we're going to set the width, but we want to put in our clause. We want to say if width is less than or equal to 0, raise value error, width must be positive. Okay, else, what are we going to do? We're going to set our internal width variable to the width that was passed in. So this is how we create a width setter. And let's do the same thing for the height. I'm just going to copy paste that because most of the code is the same, except this becomes height. We're setting our height setter. Height, underscore height as well, and this should be height as well. Okay, so now we have our getters and our setters. So we can go ahead and run that. And now this will work the same as before for getting the value, right? So r1.width. Am I doing this wrong? Because height.setter, that's that's called height. Okay, so I missed that one. Let's redo this. So now our width is 10, right? And we can set our width to -100, and now it tells us, you can't. The value must be positive. Now we could do r1.width equals 100, and that works. In fact, if we look at the value of r1, we have 100, 20, which is correct. So you can see that we didn't break backward compatibility. We didn't break backward compatibility by implementing getters and setters. That's because we did this using properties. So it's okay to leave your properties bare initially until you need to do something, in which case, go ahead and implement something like this. You can do that without breaking backward compatibility. So this isn't like Java where you should always implement getters and setters from the get-go. Not in Python. I know I'm rehashing this. We'll come back to this later, but that's kind of important. Okay, the next thing though is that I want to clean up this code over here. You'll notice that it's calling self.width and self.height. Now, there's actually nothing wrong with doing that. Why? Why did it work? Well, self.width is going to do what? It's going to call the width getter. And it's going to do what? It's going to return _width. So it's perfectly fine leaving that here this way. Now, in this case, however, maybe I want to avoid calling the method, the getter method, and so I might actually, do it directly. Kind of depends. I choose not to do that initially. I prefer getting and setting my data, even inside the class, using the getters and the setters. This way, if I have any logic in the getter that's being implemented, I'm going to pick up that logic for free right over here. And that's kind of what I want, right? But maybe in some cases you want to speed things up. Maybe there's something and you don't want this extra call to a function in order to get the value. You just want to hit it directly. That's possible too. Okay, and we'll talk about those kinds of issues later on. Okay, the other thing too is that I want to show you that I could do this. I could say R1 equals rectangle minus 100, 20. And that's perfectly fine. It allowed me to now instantiate a rectangle with a negative width. And I don't want that. So of course I could go in here and put in a, if width is less than or equal to 0, raise value error and blah, 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 and so on. But instead, what am I going to do? I'm going to do this. I'm going to actually call the setters inside my init method. And then the setter is going to handle, raising an exception if it needs to. So let's go ahead and redo this. And now let me go ahead and try and run and instantiate this rectangle. And indeed we get width must be positive. So again, I got that thing for free by using internally the getter and the setters in my class. All right, so this is kind of the basics of classes in Python. I really wanted you to understand about how you create classes, how you define classes, how you initialize values inside the class, why it's okay to have bare properties in Python classes, and if you really need to implement getters and setters, the best way to do it, which is the approach I just showed you, and also these special methods that we have that allows us to bring, standard style implementations to our own classes, right? We saw how we could use the built-in string function to actually, customize how we want our rectangle's string representation to look like. That was by using these special dunder methods. All right, thanks for watching, and I'll see you in the next video.